Okay, I'm going to go through some of the demos just because some people might never actually boot it. So I go into F1 to get to the help index, and then I go into the demo index right here, demo index. So these are beginner programs. Dot of nets. Okay, so what this is doing is it sets the device context to it makes an alias of the persistent. There's two device contexts, a persistent and a refresh device context. This is a persistent. We make an alias. This is just a structure that has a pen. It has a pen and a color and a pointer to the device context. Anyway, so we set the color. Obviously, we need our own structure to have our own color. If this other task was accessing the same device context, we would want independent colors. So anyway, so it has to have a color, then it draws a line, then it deletes the device context, press a key. This is kind of, it's filling it. It's using another name for the device context. The default, we're using a lot of default function parameters. The default is the persistent layer. Anyway, so we hit F1. We get a nice dot of nets. We went at a step of 3. That means every 3 dots we did a dot. Every 3 pixels. Now let's look at input pointer. Okay, so this is a while input pointer left, not input pointer left button. That means loop as long as the left button is not pushed. So when the left button is pushed, it stops. And it's going to plot, and then this is a global variable, input pointer position X, input pointer position Y. And it's using the device context of the persistent layer, and then when it's done, it fills it with transparent. That's what the default arguments are, transparent. So what's this going to do? It's now it's jumping around. That's because the mouse takes more than one step most of the time. More than one. Anyway, so now we hit the left button and it's done. Okay, so that was that. Now this is getting into, let's look at it. Can you see that? It's the sun and the moon. Anyway, we're using dithering. So basically we're starting to use some of the graphics routines, flood, fill, circle. We do an arc. We do an arc for the moon. The moon is an arc. We have 2 shaded regions. Now what I'm doing is every time it refreshes, it randomly generates a probability of one color or another color. So in this case, the 2 colors are light gray and black, and it sets the probability on a scale from 0 to 65535. So it's kind of ugly, but it's better than nothing. We only have 16 colors. God said that was a covenant, like circumcision, that we have 640 by 480, 16 color. Anyway, so let's analyze what else we got here. So FS is the current task, task record, and this task has a text attribute that's setting the background to black and white. I have a bug. What the hell is that? Hold on a second. 4. How was that even compiling? Well, anyway, it doesn't matter, but it's a bug. Okay. I was missing a... the background is the upper 4 bits. The foreground is the lower 4 bits. Autocomplete is Alt-Shift-Alt-A. This is autocomplete. This turns off autocomplete. Win border, document clear. that clears the text. Win max, that sets it to the maximum size, screen size. Okay, elephant walk. Okay, I jump in right away and let you see how to do a game. So here we're getting keys, and these are scan codes. The low byte in the scan code lets you get the cursor keys. U8 is a byte, and this is byte number 0. So this is the low byte. The upper bits are other stuff like shift flag and control and stuff. Not shift anyway. Okay, so what are we doing? We're using the cursor keys to move X and Y, and we are printing on the persistent layer a sprite that's that's rotated about the Z-axis. That's the one that comes out of the screen. So we're rotating about the Z-axis an angle of sine of t. So what that means is it's going to shift back and forth with the sine of the time. Every second, every 6 seconds, it's going to complete a cycle. What does it look like? Okay, so you see the elephant. Now it's not synchronized to the refresh, so we're getting some chopping. I think we can fix that if we, I'm not positive. Basically, when you're dealing with the persistent layer, it's kind of childish. I think we can say win manager sync, and it will, no, it looks just as bad. Okay. That's about all you can do with the, I don't know. Anyway, what do we have here? So this is Lowpass Filter. This is just some plotted lines, nothing exciting. It's a little bit of math. I don't know why I made a Lowpass Filter function. It's pretty stupid. Anyway, just kind of nerdy. This is audio math. So there's a sine wave. Now I made something called, that's a sawtooth function. I made a function that's a sawtooth. It's pretty simple. There's a full sawtooth, plus or minus 1. Cosine, this is just like cosine, cawtooth. Now I did triangle. This is handy. So those are just handy functions I have. I'm proud of them. Now let's do some lines. Anyway, so we're moving the X and Y randomly based on we're getting a random 16-bit signed random. Then we're taking it plus 1 minus 1 0. That's what the sine function does. If you remember old BASIC, it used to, if it's positive, it's 1. If it's 0, it's 0. If it's negative, it's minus 1. So it's just a handy function. Some of these, it's kind of like string handling. What are we doing here? Tic-tac-toe. Okay. Beeps, we can't hear it. Actually, I guess I can on the video. Control-Alt-C, I kind of... Control-C is the old-fashioned break. We do Control-Alt-C. All the special keys, all the system keys are Control-Alt. So what are we doing here? We're drawing a chessboard, or tic-tac-toe. Beep. Okay. Now let's see, Sprite Plot. Okay, we have some graphics in the source code. Control T toggles. You'll see this is a command sprite. This is the tag 1. Binary, that's the, in theory we could have other things besides sprites. Binary object number 1. Okay, so we can go on top of it, edit it, Control T, Control R. Now we're editing. it has an editor. There's a text that says welcome to TempleOS, and there's a bitmap. Okay, well, anyway, let's see what this does. This is printing and clearing and sleeping. Okay, so that's what that does. Now, this is going to write some sprites to the command line. We printed them to the command line with the sprite. Now, this is Control T, gets us to the ASCII underneath. Binary object 1, binary object 2. That's basically sprites. There's the tags. If you have the tag as a number in brackets, it automatically gets set to the binary number. Now, the reason, if you put it on a clipboard, you'll see there's more numbers. So you don't choose the number. The binary number is chosen by the editor. But if you make, if you go in and manually edit these and put them to 1, you can, now we have multiple, anyway, a repeat. What do we have here? Here's, what is this? Now we're using a file. We're going to go into another file and get the graphic sprite that's in there. This is binary pointer. I think that's what that stands for. There's the file, and we want number 2. So there we got the map again. Okay. We're printing. This is a printf repeat 12 times a character. H12 is repeat 12 carriage return. So that prints 12 carriage returns. Okay, so that's what that does. Now, ASCII organ, we're just hitting the ASCII key. It prints an icon to the command line that's active, actually. We can click on it to get a better organ. So this is sound frequency. Now we're printing that sprite to the command line. This gets tricky because we have to print a tag, and we're printing the text that's anyway, let's call it a day. Alt-Shift-V.